بكم مرة تانية في كايرو دار. My dear students of the third second stages, we are going to continue with the curriculum of the algebra, and our lesson today will discuss, or we're talking about the cubic root of the unity. This lesson is related to the complex number. If we are going to discuss what is the cubic root of unity together, we have to know that if we have the 1, the cubic root of 1 equals 1 of 3. First is 1, and the second root of 1 is omega, and the third is omega square, and these are the 3 units of, or the cubic roots of unity. We have some properties of these roots. Some of these roots equals 0. That means 1 plus omega power 2 equals 0. By the way, 3 plus 3 omega plus 3 omega square also equals 0, etc. This is the first part. As we know that 1 plus omega square equals 0, that means 1 plus omega equals negative omega power of 2. We know that together from the previous lesson of the complex number, we have I power 4 equals 1. Also, we have now omega power 3 equals 1. So, for each omega raised to the power 3n, the answer will be 1. Also, if we have 1 over omega, it will be, we can erase 1 and write omega power of 3. So 1 over omega, which is omega power 3 over omega, it will be omega power of 2. Also 1 over omega square, that means omega power 3 over omega power 2, which is equal to omega. Also, we have two important parts. First of it, the sum of each one. What is omega and what is omega square? Omega equals negative half minus root 3 over 2i, and the omega square equals negative half plus root 3 over 2 I. Let's fix this number together. This is number 2. Which of them is omega and which is omega square? The both. There is no difference. We can say this is omega and this is omega square, and also we can changing omega and omega square. So what is the relation now between omega and omega square? We have omega plus omega square equals negative 1. This is in case of addition, but here omega square minus omega equals positive or negative root 3i. This is a very important relation between omega and omega square. Let's try to solve some examples. Example number 1. If 2x equals negative 1 plus root negative 3. Prove that x power of 10 plus x power of 5 plus 1 equals 0. Okay, let's try to know what shall we do. First, we have 2x equals negative 1 plus root negative 3. We haven't any root for negative number. Then we have 2x equals negative 1 plus root 3i. That means x equals negative 1 over 2 pi plus root 3 over 2i, and this is the value of x. So it could be omega. Now if we are going to substitute against omega, so omega power of 10 plus omega power of 5 plus 1 equals 0. We don't know now. Omega power of 10, take omega power of 9 equals 1, so we have 1 omega left. Omega power of 5, subtract 3 from 5, we have omega square left, plus 1. Finally, we get omega plus omega square plus 1. This is the rule that we had before. This is equal to 0. Clear? Thank you. Let's move to example number 2. Find the value of, first, 3 plus 5 omega over 3 omega square plus 5. This is number 1. And number 2, 1 minus 1 over omega times 1 plus 1 over omega square. Let's move to solve number 1. By the way, 3 plus 5 omega, 3 omega square plus 5. What shall we do? By the way, 3 could be 3 omega 3 plus 5 omega, because this is here 3 multiplied by 1. 1 is omega power 3. Also, we have the denominator as it is 3 omega square plus 5. If we need to take a common factor omega from the numerator, so we have 3 omega square plus 5, and the denominator now 3 omega square plus 5. By cancelling, the final answer will be omega. This is for number 1. In number 2, we have to put the problem in the simplest form. We have 1 minus 1 over omega means omega square. 1 plus 1 over omega square equals omega. Then now we have to make in direct way of solution, make the distribution. 1 times 1 equals 1. 1 times omega equals omega. Negative omega square times 1, negative omega square. Negative omega power 2 times omega, negative omega power 3. Don't forget that 1 plus omega minus omega square. This is negative omega power 3 equals 1. By cancelling 1 with 1, now we have omega minus omega power 2, and omega minus omega power 2, as we know, equals positive and negative root 3. This is positive or negative root 3i. I. That was the solution of the examples. Now we are going to discuss together about some kind or the different kind of problem of the cubic roof of unity. This is an example here. First, prove that five plus 2 omega plus 2 omega power 2 all to the power of 4 equals 81. How could we solve this problem? First, we have to write it together again. 5 plus 2 omega plus 2 omega square all to the power of 4. This is left hand side. What are we going to do now? This is 2 omega plus 2 omega power of 2. This is 5. Shall we write 5 as 3 plus 2? Why 3 plus 2? Just complete the problem. This is 2 omega plus 2 omega square all power of 4. As we know that 1 plus omega square equals 0. 2 plus 2 omega plus 2 omega square also equals 0. Then we have now 3 raised to the power of 4 and 3 to the power of 4 equals 81, and this is the right hand side. Piece of cake, as they said. How could we solve this problem? Directly with applying the properties of the omega, which is the cubic root of unity. Directly we are going to solve another problem. Prove that this is 1 minus omega plus omega square multiplied 1 plus omega minus omega square equals 4. First, we have 1 minus omega plus omega squared. Take care that 1 plus omega square, so we have negative omega, and take 1 plus omega square together like that. It will be negative omega again, and here 1 plus omega, it's negative omega square and negative omega square. So negative omega minus omega negative 2 omega, and this is negative omega square minus omega square also negative 2 omega power of 2. By multiplying negative 2 times negative 2, it will be 4 omega times omega square, it will be omega power 3. 4 omega power 3 means 4 times 1 equals 4, and this is the right hand side again. Let's move to try another example, and this is very important one. Prove that one over 4 plus 3 omega plus 2 omega square plus 1 over 5 plus 3 omega plus 4 omega square equals 1. Let's solve it together. First of all, we have to simplify. This is 1. We are going to deal with the smallest coefficient, which is here is 2, so it will be 2 omega square. 3 omega means 2 omega plus omega, and 4 is 2 plus 2. Repeat the same step in the second part. This is 3 omega. This is the smallest coefficient. Then we have 3 omega square plus omega square, and this is 5. This is 3 plus 2. Take care, my dear. This is 2 plus 2 omega plus 2 omega square means 0. Now which is left? 1 over 2 plus omega. Also we have 3 omega square cancelled. It will be 1 over 2 plus omega square. Now we reach to the part of common denominator by multiplying. This is 2 plus omega times 2 plus omega square. This is by expanding. Two plus omega square times 1, it's 2 plus omega square, and we have this is 2 plus omega. Now we have to add 2 plus 2 equals 4 plus omega square plus omega, and expand here 4 plus 2 omega square plus 2 omega plus omega power 3. Now we have 4 plus omega square, this is 3, and now we have 4 plus 2 omega square, 4 plus 1 equals 5. 2 omega square plus 2 omega means equals negative 2, so 3 over 3 equals 1, and this is the right hand side. Another problem, find the value of omega square over 1 plus 2 omega all power of 2 plus omega over 1 plus 2 omega square power of 2. First we have to expand the power. We have omega power of 4, and the denominator it will be 1 plus 4 omega square plus 4 omega, and here we have power of 2 here up and down, it will be omega square, and this is 1 4 omega power of 4, and this is 4 omega square. Simplifying, omega power 4 means omega power 1, 4 omega plus 4 omega power 2, it means negative 4, plus omega power 2, and this is 1, 4 omega square, 4 omega power 4, this is omega power 1, it will be also 1 minus 4, so we have omega plus omega square over negative 3, omega plus omega square means negative 1 over negative 3, then the final answer will be 1 over 3. To another example. Prove that five minus 4 omega plus 11 omega square over 1 minus 2 omega plus 3 omega square equals 3. Let's start by left hand side. Left hand side, we have to write 5 minus 4 omega minus, this is 11 omega square. We can write something like that. This is omega square equals negative 1 minus omega. That means 11 omega square means negative 11 omega minus 11. Also 1 minus 2 omega. 3 omega square means negative 3 omega minus 3. By simplifying now, 5 minus 11, it will be negative 6. Negative 4 omega minus 11 omega, it will be negative 15 omega. 1 minus 3, it will be negative 2. Negative 2 omega minus 3 omega, negative 5 omega. By taking highest common factor is 3, it will be negative 2 minus 5 omega over negative 2 minus 5 omega, cancelling, then the final answer will be 3. This is the right hand side. To another example. If 1 minus t, 1 minus I multiply x plus I y equals 19, 1 over 2 minus 3 omega square plus 1 over 5 plus 3 omega square. Prove that x equals y equals 7 over 2. This is the solution. Now we have 1 minus I times x plus I y equals 19, and let's move to make a common denominator. It will be 2 minus 3 omega square multiplied by 5 plus 3 omega square, and we have 5 plus 3 omega square plus 2 minus 3 omega square. By cancelling 3 omega square with 3 omega square, now we have 19, and we have here 5 plus 2 equals 7. So what about the denominator? So we have 2 times 5 is 10, and this is positive 6 omega square, and this is negative 9 omega square, and also it's 9 negative 9 omega power 4 means omega. So it equals to 19. Let's simplify the denominator. We have 7 and we have 10, and this is 6 and this is 15. Now we have negative 5 omega square, negative 10 minus 9 omega square minus 9 omega equals 19. This is 7, and we have here 10 plus 9. Now we have to write 1 minus I multiplied x plus iy equals 19 times 7 over 19, which is 7. Let's simplify this part. We have 1 x plus iy now equals 7, 1 minus I. So we have another way to we can simplify this part and make two equations together, or by using this method to get one equation directly. So by multiplying by the conjugate, this is 1 plus I and this is 1 plus I. So let's try to solve. This is 7 and this is 1 plus I and this is 1 plus 1. That means x plus I y equals 7 over 2 plus 7 over 2 I. That means x equals y, both of them equal 7 over 2, and this is the final example of the cubic root of the unity. I hope that you have a good understanding about this presentation, and I promise you to meet you soon. أترككم في رعاية الله، والسلام عليكم ورحمة الله وبركاته.